Today we're going to be factoring again, but instead of factoring just quadratics, we're going to be factoring polynomial functions. And sometimes when we factor these polynomial functions, one of the results that we'll get, or one of the factors, will be a quadratic function that we can factor even further. So the first thing that I've told you guys when factoring is to always look for a GCF. So in this problem, we can factor out a 3, but also an x. So we're going to have 3x, and we're left with x squared plus 10x plus 25. Now, there's two things we can do right here. One, you could realize that this is a perfect square trinomial and go right to x plus 5 squared, that quantity squared. Or you can always say, since our a value is 1, what two numbers multiply to 25 but add to 10? And that is 5 and 5. And then you can take this further and write this as 3x times x plus 5 squared. This is factored form. Now for the next one, we only have two terms here, but they also have a 2 in common that you can factor out, and a y to the third. So we're going to factor out 2y to the third, and we are left with y squared minus 9. If you're ever unsure if you factored something correctly, remember you can always distribute back in and see that you get the same thing that you started with above. So we're not done yet, because this is a difference of two squares, where we can write that as y plus 3 and y minus 3, because the square root of y squared is y, and the square root of 9 is 3. So difference of two squares is something that we are still going to be using quite frequently in this lesson. And then finally, we can factor out a 4z squared as a GCF, and we're left with z squared minus 4z plus 4. And again, this is a perfect square trinomial, but it might be easier for some people to say what two numbers multiply to positive 4 but add to negative 4. Well, that's negative 2 and negative 2. So then our final factored form becomes 4z squared times z minus 2 squared. Next, we'll look at two special factoring patterns, the sum of two cubes and the difference of two cubes. It might be useful for you to know the perfect cubes. Just like how we had the perfect squares, numbers you can take the square root of and get a whole number result, the perfect cubes will allow you to take the third root, or the cube root of a number, and get a whole number result. So the cube root of 1 is 1. The cube root of 8 is 2. The cube root of 27 is 3. The cube root of 64 is 4. The cube root of 125 is 5. The cube root of 216 is 6. The cube root of 343 is 7. The cube root of 512 is 8. The cube root of 729 is 9. And then last one, the cube root of 100 is 10. So when you see these numbers, along with another thing raised to the third power, like an x or a variable, we should be looking at the difference of cubes, or the sum of two cubes. So for example, the sum of two cubes is this long, ugly mess here. I always tell people that it's easier to identify your a and b and then just plug it into that formula. So your a and b for this one, you want to take the cube root of that. Well, the cube root of x cubed is x, and the third root of 8 is 2. So my a is x, and my b is 2. So now I'm going to plug those into this formula here. And we already have the a plus b, or the x plus 2 part right here. So then it's going to be x squared minus ab, so 2x. Because remember, it doesn't matter if you say x times 2 or 2 times x. and then plus 2 squared, or 4. And that would be it. The difference of two cubes, you see that they look very similar, except the first one has a minus instead of a plus. And then in the second factor, we have a plus instead of a minus. So here we have x to the third minus 1. Well, the third root of 8x to the third, you have to take the third root of both. So the third root of 8 is 2, and the third root of x to the third is x. So a would be 2x, and b would be the third root of 1, or just 1. So that will give us 2x minus 1, so a minus b, times a squared. Well, if a is 2x, we have to square both things, the 2 and the x. So instead of saying 2x squared, it's going to be 4x squared minus, plus a times b, so 2x, plus b squared, well, b is 1, so just 1. And that would be our factored form. So these problems, they're not that difficult once you identify a and b and you have this in front of you. It becomes difficult if you're trying to do this right away without identifying what your a and b would be, or if you're not looking or have this memorized yet. So let's do a couple more, and then I'm going to have you try some. Here we have z to the third minus 125. That minus means it's going to be a difference of 2 cubes, so we're going to use this formula right up here. So your a value is going to be the third root of z to the third, so z, and the third root of 125 would be your b value, so b is equal to 5. So then we're going to do a minus b, so z minus 5, and then parentheses a squared, so z squared, plus a times b, so 5z, plus b squared, so 5 squared is 25. And it's good habit to see if you can factor any of these. Most likely you won't be able to, but always get in the process or the habit of looking to see just in case. So I'm going to do this one just because it's a sum of cubes, and then that way down here you can try a difference of cubes and then a sum of cubes. So I'm going to look for a GCF first. The greatest common factor between 8x to the third and 64 is 8. So then it's going to be x to the third plus 8, which is a sum of cubes. Now we can factor this, x to the third plus 8, and we did that up here in this example. But factoring out that GCF made it significantly easier. So our a value is the cube root of x to the third, or x, and the cube root of 8 is 2. So then we can use our formula. Don't forget about this 8. So we have x plus 2, because we're at the sum of cubes, times x squared minus 2x plus 2 squared, or 4. And like I said before, if you are unsure if you factored this correctly, you could always multiply this all out and you should get the original. I know that's a lot to do, but it is a way to double check. All right, so I want you to try these two down here on your own. So please pause the video, try those, and when you're done, you can look at my work and answer and see if we get the same thing. All right, so here are the answers that you can check. The one on the left, letter B, you need to factor out a negative value because we want our leading coefficient to be positive. So once you factor out a negative 2d squared, you're left with d to the third minus 125, and then you can do your difference of 2 cubes. Then over here, once you factored out a 2b squared as your GCF, you're left with 8b to the third plus 343. Now your a value in this one would be 2b because you're taking the third root of this as well, of the 8. So then you might be wondering, how did I get this negative 14b? Well, remember, in the middle, that middle term is a times b. Well, a is 2b, and b is 7. So 2 times 7 is 14. So that's how we get 14b. So I hope that those were not too bad once you're able to figure things out. Figure out your a and b. All right, now on the next page, we're going to do factoring by grouping. And the thing with factoring by grouping is that we have done this before when we did quadratics. When a was not 1, I said that we could do guess and check factoring, but I wasn't a big fan of that. But we could do something called factor by grouping, and we broke up that b term into 2 separate terms and then group the first 2 things together and the second 2 things together. It's the same idea here. So the way you can tell that you might want to try factoring by grouping is if you have descending exponents. So what do I mean by that? You have x to the third, x squared, x to the first, and x to the 0. And what you want to do is look at the first 2 and say, what can I factor out of those 2 terms? Well, you can factor out an x squared, so I'm going to do that. And then I'm left with x minus 2. And then we say, what can we factor out of this? Well, you might say a 9, but because this is negative, you factor out a negative 9. And then you're left with x minus 2. If these 2 things match, that means you're in good position to do factoring by grouping. So we write that once, x minus 2, and then our leftovers is x squared minus 9. Now we're not done. This is a difference of squares like we had at the beginning of the lesson. So my final answer is going to be x minus 2 times x minus 3 times x plus 3. And now we have our factored form. And this would be useful if I asked you to graph this problem. If I said graph this polynomial function, we've never really talked about that. But now that we can factor that, we've talked about how to graph this with no problem. Letter B. We can factor out a 5, and we're left with 2z. Sorry, we can factor out a 5z squared. And we're left with 2z plus 3. And then we can factor out a 2, and we're left with 2z plus 3. We see this twice. It's the exact same thing, so 2z plus 3. And then our leftovers, 5z squared plus 2. And now I ask myself, can I factor any of these? And the answer is no, we cannot factor any of these remaining or resulting factors. So we are done. All right, I want you to try this one down here. Pause the video and unpause it once you're done to see the answer. All right, so you can see once we factor that, we had x plus 2 times x squared minus 25. And then that x squared minus 25, again, is a difference of 2 squares. So then we factored that and got x minus 5 times x plus 5. So this would be your completely factored answer. Now, on the next page, we're going to talk about something called quadratic form. And what that means, you can think about like even quadratic functions. Well, that's obviously a quadratic form. So this would be quadratic form. And we had x squared plus 3x minus 4. And we would factor that. We had something squared, x squared, plus 3 of that same something, x, and then minus a constant. But what if this something itself was x squared? instead of just being x? What if this middle term said 3x squared? Well, if we had x to the fourth plus 3x squared minus 4, we have something squared plus 3 of that something minus 4. It just happens to be that this something, that thing being right here with the 3, is x squared. And when we square x squared, we get x to the fourth. This means we could do anything. What about x to the 10th plus 3x to the 5th minus 4? We can factor that the same way because our something here is x to the 5th, and we have that something squared in the front. X to the 5th squared, multiply the exponents, you get 10, plus 3 of that something, x to the 5th, minus a constant. So this is in quadratic form, and we can factor those the exact same way we did quadratics back in Unit 1, things that looked like this. What that means, though, is that our factors are going to look different. Our factors, instead of being, like in this form, x minus 1 times x plus 4, if we're looking at this one, we would say x squared minus 1 times x squared plus 4. Whatever this something is, this middle term, that's going to be the x at the front of your parentheses. So we have that down here. If we're x to the fourth, it's going to be x squared plus an x squared, the thing in front of both parentheses. And then if it was the sixth, well, half of 6 is 3, so x to the third and x to the third. Because when you multiply these together, you would get x to the sixth. So let's look at some examples. We'll do a couple of these together, and then I'll have you try some on your own. So like always, we want to look for a GCF. The GCF of letter A, example A here, is 16. So I'm going to factor out a 16, and then I'm left with x to the fourth minus 16. This is actually a type of difference of squares, because the square root of x to the fourth is x squared. So we can write this as x squared plus 4 times x squared minus 4. And if we were to FOIL this out, multiply this out first, outside, inside last, we would get x to the fourth minus 16. Now, this isn't done yet. This is also a difference of squares. So now we write that as x minus 2 times x plus 2. So this would be our factored form. Over here in letter B, we're going to factor out a 3m squared, and that's going to give us m to the 10th plus 18m to the 5th plus 17. Now, again, we're going to factor this, and this is in quadratic form because we have 18m to the 5th. m to the 5th is our something, and our leading term is that something squared. M to the 5th squared is m to the 10th. So let's think about what two numbers multiplied as positive 17 but add to 18. Well, that's going to be 17 and 1. So this is going to be our factored form. M to the 5th plus 17 and m to the 5th plus 1. But of course, don't forget about that 3m squared in the front that we factored out at the beginning. So this would be our final answer. I'm going to do this one down here, and then I'll have you try the rest. So factor out a 10 from both of these, and we're left with x to the fourth minus 1. This, again, is a difference of squares. So, oops, x squared minus 1. Because the square root of x to the fourth, again, is x squared. This is also a difference of squares. So this would be our final answer. So really knowing the difference of squares pattern, that shortcut, makes life a heck of a lot easier here. So I'm going to have you guys try the rest of these. Once you're done, unpause the video and we can compare answers. All right, so check your answers. For that first one, letter C. Once you've found two numbers that multiply to 45 and add to negative 14, negative 5 and negative 9, you then had to do the difference of squares with x squared minus 9 to get this answer. And actually, this should not be squared. So that would be your completely factored expression. And then down here, you can see both of these answers right here. After you factored out the GCF, you actually got the exact same. You actually got the exact same result once you factored out the GCF. And the two numbers that multiply to positive 6 but add up to negative 5 or negative 3 and negative 2. So this is why I stressed in Unit 1 that factoring was going to be super important and coming back to us, because if you were struggling with factoring back then, this may be a struggle now because we really are relying on those skills. So thank you for watching. Make sure to like and subscribe.